Hi class, this is the fourth and final part of section 6.4 on logarithmic functions. Okay, so once again, we will use the fact that y equals log base a of x if and only if a raised to the y power is equal to x. Okay, so we want to solve these two equations. So we have both of them are logarithmic equations. So the first one, log base 5 of x is equal to 3. So what we're going to do is rewrite our logarithmic equation as an exponential equation. So we'll have 5 raised to the third power is equal to x. And then we're basically done. So 5 to the third power is 125. So the answer is x is equal to 125. Okay, part B, same thing. Rewrite the logarithmic equation. So it's log base 3 of 3x minus 2 is equal to 2. So rewrite it exponentially. The base is 3, so 3 raised to the second power is equal to 3x minus 2, and then just solve for x. So 3 squared is 9. We can add the 2 over. So we'll have 11 is equal to 3x. Divide both sides by 3. And our final answer is x is equal to 11/3. We do need to make sure that our answer is a valid solution. So when I plug in 11/3 to my x value, I have to make sure that I'm not taking the log of a negative number. So let's just plug in 11/3 for the x value. All right, so the 3's cancel. 11 minus 2 is 9. So log base 3 of 9 does in fact equal 2. So we went further, we checked it to make sure it was the correct answer, but minimum make sure that you're not going to be taking the log of a negative number. Okay, so two more. Part C, we have the equation log base 5 of the quantity x squared plus x plus 13 is equal to 2. All right, so again, rewrite the log equation exponentially. So we'll have 5 squared is equal to x squared plus x plus 13. So 5 squared is 25. So 25 equals x squared plus x plus 13. Subtract the 25 to the other side. So then we have x squared plus x minus 12 is equal to 0. So we'll factor it. We're looking for two numbers to multiply to be negative 12, add to be 1. So the numbers are 4 and 3, and the 3 needs to be negative. This way they multiply to be negative, but add to be a positive. So this will factor to x plus 4 times x minus 3 is equal to 0. And we get x is equal to negative 4 and x is equal to positive 3. So we do just need to check to make sure that we're not taking the log of a negative value. The 3 is going to be fine since 3 squared is 9 plus 3 plus 13. So those we're just adding three positive numbers together. The negative 4 is also okay since the first thing we do is square it. So negative 4 squared is 16. We would then subtract 4 but add 13. So again, we were just checking to make sure we don't get a negative number, and it does in fact work out, right? So this is even. Sorry, this shouldn't have been, this is a 13 right here. Okay, that way when we add that, so it was positive, but it wasn't working out when I was checking. So this is 16 minus 4, so 12, and then add 13, so then we're at 25. So again, minimum, you just had to make sure you weren't taking the log of a negative number, which we were not going to do. But when you plug in negative 4, this should also equal 25, since log base 5 of 25 is equal to 2. Okay, so we checked both of these solutions are valid solutions, so I will circle both of them. Okay, part D is a little bit different because this one starts off as an exponential equation. So we are still going to write it the other way, so write it as a log equation. The base is e, so this, again, you could write it as log base e or just go directly to the natural log. So log base e of 13 is equal to 1 plus 2x, again, equivalent to the natural log of 13 is equal to 1 plus 2x. I'm going to subtract 1, and then we'll divide by 2. So the natural log of 13 minus 1 is equal to 2x. Divide by 2. And our final answer is x is equal to the natural log of 13 minus 1 over 2. And just a note, the natural log of 13 minus 1 is not the natural log of 12. Order of operations, you would take the natural log of the number 13 first and then subtract 1 from it. Okay, complete and turn in through Canvas. So example 7, part A, graph the function. So we have y equals log base 2 of x plus 3. Include 3 points on your graph and any asymptotes. State the domain and range of the function. And then also solve this logarithmic equation. Log base 4 of the quantity 3x minus 7 is equal to 2. Okay, let me know if you guys have any questions. Good luck.